Hey guys, so I just wanted to make sure that I put a video out there for you guys before Friday ended. I'm sorry I couldn't be there. I have not been feeling well all day, but I wanted to make sure that I worked through a couple problems for you so that you could better understand what I was asking you guys to do for the assignment. That one's fine. So when we were in class, what we did was transforming f of x and g of x, right? Hold on, I need to change that. 1 second. And what we were doing is we were either adding them or subtracting them or multiplying them. And when we did that, we created these different transformations, right? I knew there were still some issues right here with making sure that if you have f of x minus g of x, that your minus is actually negating whatever g of x was. So it's almost like we can bracket that part right there and say we want the opposite of g of x so that we can perform the operation. Hold on, I'm getting a better eraser. So when we have these different functions, and if you can hear my cat in the background, I'm sorry. When we have these different functions, we can also do those functions evaluated at a number, okay? So if I have f of x equals 2x plus 1, and g of x equals, let's do x squared plus 2x plus 1. So I've got a quadratic and a linear. If I have both of these, and let's say I want to combine them, and we can do f plus g of x. Well, we know that we would combine our like terms so that I'd have x squared, because there's only one x squared, plus 4x plus 2. And this part you seem to understand pretty well. Well, if I do the same function, right, that same operation, f plus g, and instead of x, let's say I want to put a 2 in there, well then I would have, wherever there was an x, now I'd put a 2. So I'd have 2 squared plus 4 times 2 plus 2. So then my new function evaluated at 2 would be 4 plus 8 plus 2. Excuse me. So we've got 14. Okay, and this could work for any operation that we're going to do this with. Another way that we could do this is, let me just erase this. Okay, we know that this is 14. Okay, I could also do f of 2 plus g of 2. So what I did this time is instead of doing the operation f plus g first, I'm going to evaluate f at 2 and evaluate g at 2, and then I'll add those two numbers up. So f of 2 would be my f of x function, 2x, but I'm going to put a 2 there instead, plus 1. So there's f of 2, plus my g of x function, which when I replace with 2 is going to be 2 squared plus 2 times 2 plus 1. And now we can see if it actually equals 14 like we did the other way. So f of 2 is equal to 5. And then g of 2 is going to be 4 plus 4 plus 1. Sorry, one of my kids came in. And so then this total is the same as f plus 2, or excuse me, f plus g of 2. So the way that you do it, it doesn't matter. You can either do the operation first, which is the way I like to do it first, or you can evaluate each function at the given number first. Either way does not matter. You can see that they both equal 14. So now, hopefully that explained it for evaluating at a function. Now let's talk about the compositions pieces. We talked briefly about what a composition was. And so this was, if I have f of x equals 2x plus 1, I'm going to use the same function. And then g of x equals x squared plus 2x plus 1. Same function. If I want to compose them, then I would have f of g of x equals this new function. So remember, if this were a number right here, we would just plug that number into whatever f of x was. So then I'm going to take that g of x, I'm going to do the exact same thing, except I'm going to put a whole function in the place of x. So we have 2, and I'm pulling this from my f of x function right here. 2 times x, which in this case we're going to write g of x. And I'll actually do that just so we can see that. Plus 1. If I bring this down further, I can expand my g of x, which is x squared, plus 2x plus 1 plus 1. Because remember, we still have the 2x plus 1 as our main function. I would distribute this 2 right here through the quantity x squared plus 2x plus 1. So 2x squared plus 4x plus 2 plus 1 hanging out here on the outside. And so my final answer is 2x squared plus 4x plus 3. All done. So when you're doing compositions, there is a little bit more work involved, but it is the exact same process as if we had taken this g of x, okay, and made it a 2 instead. Right? If I had just taken this thing, if I had put a star here, then I'd put a star here and a star here, right? What we're doing, it doesn't matter if we have numbers or functions or symbols, the process is the same regardless. Now, the notation on the paper is a little bit different on the maze. What the notation that I've been using for this is f of g of x, where you can see what goes inside, right? This g of x. On your paper, it's f open circle of g of x. Okay? That just means that your g is inside your f. All right? The g is inside your f. These two notations are exactly the same. It's just one is more symbolic than the other. All right. So now, if we take this, and now let's try to evaluate this at a number. Again, I like to do the operation first and then put the number in. So that's the way I'm going to show this time. We're going to use f of g of x, but instead of x, f of g of, we've been using 2, so let's do 1 because 1's easy. So then I would I'm looking for f of g of 1. Okay? That's another way to write this. So my f of x is 2. Instead of x, I'm going to write my g of x function, x squared plus 2x plus 1, and then finish my f of x function. Distribute the 2x squared plus 2x plus 1 plus 1. Oh, excuse me, that should not be plus 1. It should be plus 2, excuse me. And that should be 4. Can you tell it's late for me? Okay. Combine like terms. 2x squared plus 4x plus 3. This part right here takes care of that part right there. So now we still have to evaluate at 1, not multiply. Let me write that. Not multiply. Yes. So we're going to take the 1 and it goes into that x. It also goes to that x. Okay? So we'll have 2 times 1 squared plus 4 times 1 plus 3. So this is 2 plus 4 plus 3. My answer is 9. I hope that made a little bit more sense to you guys. Please feel free to send me a message on Remind. I've got my phone. I'm kind of going in and out of sleep right now because of whatever's going on with me. I will get to the message as soon as I can. Take a picture. If you're worried that what you're asking isn't being conveyed correctly, take a picture and I can help you out, okay? Until then, though, let me know if you need me to explain this a little bit more. I can set up another video to help you guys out. But I think that's it. All right, guys, have a great weekend. Bye.